Hello folks, well we're on to the next repair. Whilst doing the stereo master bit by bit, we have got a walkie-talkie. We've only ever seen one of these ever before in 40 years. So we'll look through it together. Because it's a Kaiser CBX40. But you'll know that because of the title of the video. It's come from the same customer as the Binatone Long Ranger 40 and the Binatone Long Ranger 6, which we did last week or the week before. He's also sent, sorry, I should have said 12, Binatone Long Ranger 40, Binatone Long Ranger 12. He sent in a Long Ranger 6. So I was disappointed when I did one of these, because they're not 4 watts, in line with a lot of German ways of selling things. 4 watts means about 2 watts. This is input power. American viewers, walkie-talkies were sold on input power in America, so sets which were like 3.5 watts output would be 5 watts input, and it would say 5 watts on it. And it was input power, so it was disingenuous, and so is this. Reminds me of Volkswagen fuel figures. So I think it was quite rugged and all that, but when we did the range test, it was as disappointing as you'd expect. But nicely made. So you get a loaded rubber duck. I think that's all you do get, isn't it? Yeah. So you're not going to get very much range. I'll just carefully take this note out, in case it's got something personal on it. Oh my goodness, a small plastic screw fell out of the PTT button. Right. That small plastic screw is in fact one of those screws for holding an output transistor onto a heatsink. So it sounds like the output transistor is in free air. So it's very important that goes in. What on earth's in here? Oh, you get a little pouch for an earphone. Nice little touch. So I don't have an instruction book on file. Carrying case. Zipped carrying case. Let's hope there's enough sockets to enable me to service this without no, there aren't, are there? So although we've got an earphone socket, we haven't got an aerial socket. Oh, of course we have. Silly Mr. Me. Yeah, fine, take that back. We have. Brilliant. Right, so we'll connect it to our BNC. That's a far better arrangement, but that's loose. It's supposed to be a BNC. Yeah. That's actually impressive. Because you've got so much better for loss than using a PL259, and you don't want to be losing power on a set like this. I don't know where we're going to find a BNC adapter though from. Huh. Yeah, well, I'll cross that bridge in a moment. So if we opened up the battery door with a massive screwdriver, we'll come to a nice condition 8-pack battery. I've said before with the Binatones that use this arrangement, you sometimes see these kind of products offered on eBay without the battery pack, which is readily available, and we stock the 8s and the 10s, and you just see it like this with a 9-volt battery, little transistor radio battery on there, and they go, oh, it's in working order, and you think, yeah, right. serial number? No, there's a plate where there would be a serial number, but there isn't. So we'll open it up, because I don't want to operate this with the output transistor in free air. So do you remember we were doing, well, not many of you will be watching our Stereo Master project, the 2026, when I took our unit out of storage so I could fix the customer's chassis. I found our turntable mat was all knackered, I think the best way. Anyway, Andy's sending me a turntable mat in the like the pictures. That's nice. And I'll tell you what else. We're struggling with power leads, aren't we? One of the viewers has kindly sent me 2 of the square type of power plugs, rewirable ones, to use with radios like the LCO communicator, Serpent UK 4000, Manakestrel, and so on, and others that use that square one. But this other viewer has, he's another dealer as well, he's made these on his laser cutter, an adapter plate, so we can fit the Amstrad square round type, which we stock, because we've got both sides of these in stock, and that makes a right neat job, because we've got to the stage now where there aren't any of these connectors left. So I think that's absolutely brilliant, and he's going to send me some samples. I'm going to try and get a price out of him so we can offer those to people who need that happening. So that's good. It's a nice little hive of activity, isn't there, in trying to keep these sets on the road. So that transistor should be there, and that's it. Can you see it is there, the other half of it? So it's snapped off, and because of that, the transistor is in free air and not getting its heat dissipated. So I've no doubt he's not used it such that that's burnt out, but that would be what would happen. So hopefully we can get rid of what's left the other way. That coil's very close. There we are, we've got it out. So, glad he pointed it out, because I might not have seen that. So we have an LC7137 synthesizer, and its reference crystals are there, and daftly they've managed to get wax on the trimmer capacitor, which is not something you want. It's all good doing the VCO coil, but not the trimmer capacitors. So that's a poor show. So we'll have to work out what's what. I'll do a photo, because I need to have some details of these for future reference. I'm thinking the transmitter is going to be 1, 2, 3, 4, and then this filter, and I'm expecting the receiver is going to be 1, 2, 3, 4, 5, and the detector there. Is this an S meter or just a battery meter? I think it's just a battery meter. I'm trying to find some presets on the board. So we've got VR3. I can't actually see any others. So what does it use as an FM system chip? An MPS 9.5 something. Isn't that the low power version of the MC3357, which by low power I mean takes less current? I think everything's preset apart from that. So that's going to have to be deviation, isn't it? So I bet VR1 and 2 are the squelch and the volume. So not too many adjustments. Oh, there's one up there. Oh, there's two. There are 2 more. We'll come to that. In that case, That could be squelch. Squelch, deviation and something. You've got a call tone. That's would be handy to set the deviation with. So how many volts is it? Well, that's a novelty, isn't it? So we'll run it at 12. Power might be external power, but we don't know whether it's centre positive or not. So we're going to have to set our power supply up for really low current in case it's a short circuit. So I'm going to set the power supply to 300 milliamps, so that if it is a short circuit, it will shut down instantly. Making sure the radio is off, which it is. Switch the power supply on. I'm switching on at 9 volts, 300 milliamps. Now I'm going to switch the radio on. And that's obviously the right polarity. Oh, display's on a switch on the side, so it's even showing something at 9 volts. Let's go over to channel 20. So channel 9 switch even displays that, and high-low power. I'm not going to run that, just for safety, put that to low power. Our battery meter's there. So there's two things I need. No, we can't proceed without sorting that out. So I'm going to pause the video. I've got to tighten that up. By the way, this is a plastic case, even though it looks metal. Right, so I've tightened that up and managed to get a little spanner in and hold it with pliers at this side. Then I've used the hot glue gun just to help it stay in place. It is important it's quite tight, otherwise it won't make its earth connection to the chassis, and that will affect range. You know what, the whole idea of going to Mr. Chippy's workshop was to get that screw sorted out. I'll just go again. Right, I've done that. As you can see, we've got a new screw in the heatsink now going all the way through, so that's bolted down properly, so we'll be able to dissipate its heat. Let's put these knobs back on. These are difficult to get off, with them being flush with the case, nothing to really grip. Right, once again we'll power it up. This time we'll connect it to an aerial. There's no electronics under the board. You know what, I wanted a BNC adapter. I'm up and down like a yo-yo. Right, so with an appropriate adapter, let's hope it still works. .12 volts. High power. Picture in picture on. Test set to low power because the radio's going to be under 3 watts. And we've got no transmit. That's interesting because we should have. I'll just drop it to low power. So it's working on low power. Let's go back to high power. It's working on high power. 1.1 watt. Let's put the squelch on. Was it about 1.5 watts we got out of the last one? I think it was. So channel 40. .15 and channel 1 1.1. Low power, go back to channel 20. At least it lights up when you change the channel like the realistic does. Go to low power and it's 360 milliwatts. Back to high power, current is 477 milliamps. So deviation, wallow. Oh, so let's just check the tunings in. Wallow says 2.4, which could be right. I think while we're doing deviation, I'll go over to the test set and verify what we've got. Wow, it's 2.5, yeah. So both test sets agree. The only trouble is, am I going to upset it when I go through looking for presets? So knowing that the Marconi test set is reading correctly, because it doesn't always, on deviation, only on deviation, because it needs the capacitors doing in the meter. So we've got 2.4 there. I'm going to go in with the cold tone. Oh, it does it like a bleep, does it? And try and guess which deviation is going to be. I would think it's going to be that one. Tell you what, we'll use our constant source. So isn't that one? Isn't that one? Oh, there's one down there. Isn't that one? This surely has got to be squelch. Isn't that one? I've upset squelch, haven't I? Well, it's got to be one of them. Well, that's bizarre. See what we're getting with a whistle? Voila, it's still the same. Put the other glasses on. One, two, three, four. Right, well, one of these is going to be, let's do a little drawing before we do a proper photo. So one of these, that's the aerial, there's the channel selector, there's the PTT, I've got a heat sink there, I've got two coils there, coil there, 1, 2, 3 there, one there, and then one there and one there. So we've got a preset there, we've got a preset there, we've got a preset there and a preset there. That is VR3. That is VR5. That's VR4. And that's VR6. So we're going to do a process of elimination. One of these is going to be low power. So let's key it up and look at power. So now I've got 360 milliwatts, which is exactly what we had before. So is any of these power? That's not. That is. So VR4 is low power. Go back to high power. I think one of these, because this is, I think it's a power meter as well, I think one of these is going to be the power meter, and I'd expect the one up there to be the power meter. So VR6 it is. So one of these is going to be squelch. Just put that on the signal generator. That's why I need to make notes, you see. Having only seen one in 40 years. Right. So, squelch to full. Trying to put this in a position that it's going to be obvious when I hit the squelch one. So I think it's going to be that one. It is. Well, it only leaves deviation, doesn't it? Which has to be that one. Back to the oscillator. do this on low power. Let's go back to the main meter. When we get to the main meter, there it is. That just doesn't make sense. There's no way it's going to have a power level. I'm going to check. Go back to transmit. 1.1 and a bit. No. The thing is, it's not where you'd expect deviation to be. I think we're going to have to come back to that. It doesn't have a signal meter, does it? You know what? It has a signal meter. I reckon. It works the opposite to usual. S9 is on the extreme left. No wonder I'm looking confused. I wasn't expecting that. So there's S9. Right. So deviation is somewhere. It's not wrong. Point is, it isn't wrong. It's spot on. But I want to know where it is. Anyway, we'll get through everything else. But at least I now know I'm not upsetting anything. Right, we'll get on with the tune-up. So, make sure we're on high power now. We are. 1.1 watt. This should be where the transmitter starts. It does. That wasn't quite at peak. That wasn't quite at peak. These are filters. So I really need to do this with the spectrum analyzer, but I'm just going to see if they're anywhere near. Yeah, they are. I don't want to go far with those. Right, I think that's going to be a receiver. I'm just going to prove it by twiddling it and putting it back exactly so. Good. So hopefully are a bit more balanced. So it's 1.25 watts. channel 40 1.2, and channel 1, let's hopefully it's 1.2 as well. It's 1.28. So we've moved it around a bit, but we've got a little bit more for what it's worth. Might get an extra foot range on it. So that's about what I was expecting. They're not going to be more than 1.5 watts. I'll tell you why they're not going to be more than 1.5 watts. Because that transistor, its absolute maximum is 2 watts. So it's never going to be at its absolute maximum, is it? So there you go. So anything about anywhere near 4 watts. Oh, I had one and it was 4 watts. No, you didn't. Oh, you were running into a Zetagi meter which was lying like they usually do. Right, so now with that, now we know we're running at its maximum capability, we'll do the meter and we know that the meter is VR6. There we are. So that's that. Current consumption 495. Low power, we want to set that for 400 milliwatts. It's 440 because when I set it roughly, didn't I? And it was before we tuned it. That's that one, which is VR4. There we go. Just for your information, it's 300 milliamps at 400 milliwatts, which is nice and efficient. So that's good. What we haven't done is frequency, so we'll put the frequency counter on. You know what, I've gone and set those two on channel 1, haven't I? So just need to check that the meter is reading. It is, and we just need to check it's still 400 milliwatts on. It is, so that's luckily it didn't cause an error. When there's a display is not on all the time, it's easy to make a mistake anyway, but there we are, channel 20. So I was going to say deviation. I know the deviation is right, but I need to still get to the bottom of where the deviation preset is, and we'll come to that. I'll get a magnifying glass and 8 pairs of spectacles. Frequency. Let's go back to low power. 2779100. So it's not really out, but it needs pulling up. I do not like it when these have had wax in them. It won't quite go. That's an age thing. It doesn't matter. 2779120. Now this test set's not been on above 20 minutes, and I think it'll be about on frequency. It really doesn't matter. It's well within. So there we go. I mean, it's not bad for 40 years old, is it? So we'll now see where the receiver is. So we'll plug the test gear into the earphone socket, give it a bit of volume, put the gear on, S9 signal on the signal generator, dirty volume control. Okay, so we'll now go to the oscilloscope. Oh no, we'll get the before figures first. Tell you what, it's ever so good. This BNC makes all the difference. 0.85 microvolts. 0.7 microvolts, and if it does 20, which it does, it's 3. We're going to come back to squelch when I set it. We can't do it before because I had to mess with the controls. Right, let's go through the receiver, and we'll start by looking at that on the oscilloscope. Just give it a bigger waveform. I'm expecting that to be the detector. That tool doesn't fit properly, which surprises me, so I'll have to use the wrong one. That was slightly out. There's an IF under there, IF meaning intermediate frequency for those people who don't know. So we're going to go to the synad meter. No, I'll tell you what, we'll look at the shape first. Right, over to the synad meter. I'll be surprised if we get anything better out of this. We're down to about 4 dB, so we can see what we're doing. I think we're going to be at the front end here. I can't see a difference there. Tell you what, there's a difference there though. Put a bigger signal on. That's it, folks. So have we made any difference? 0.85. I've got it in the wrong box anyway. Not 0.7. We've now got 2.5. It's improved the quality with the detector. So no, there's no variation there, but it's very good. It's probably better if I held on to the chassis. Let's have a look if that's the case. Yes, it is. You know what? It's actually worse if I hold on to the chassis. Yeah. Good. So that's that done. Squelch. I'll go back to the internal speaker. You need to back that off till it opens up, which is there. Just put that attenuator on the screen for you. So we're at 100 microvolts, S9 equivalent. Just check that we're there, right? No, we've got it too weak. Still too weak. That's it, 100 microvolts. We've got it. Don't often get that on a handheld. It's got good strong squelch, which I like. So now we'll do the squelch test. So with the signal generator parked at 0.3 of a microvolt, we turn the squelch down on the radio till it hisses. Set threshold. Switch the signal generator back on. Straight in. Well, not quite. It's coming at 0.71. Really good. We've just got this volume control to clean, so I'll just turn the power off and there we go. Okay, so clean that. Good, that's it, we're done, apart from the deviation. So, although it can go out because the deviations are out, I just can't imagine it being factory preset. You know what? That's either another reference crystal or it's crystal filtered. Isn't underneath like that. Take that. Exactly like the binder tone. That's the deviation preset on the speech processor module. No wonder I can't find it. It doesn't need adjusting. That's deviation. My goodness, you've got a microchip and 4 transistors. That's a pretty good speech processor. It should sound fantastic. Ah, good. We'll put the lid on. This does look fun. There we go. Yep. Well, I've just told Mr. Chippy we've got a on the air test in the not too distant future. So, I mean, they're nice sets as long as everybody's aware they're not 4 watts. I've not put that pillar back, have I? So the back of the case is metal and the front of the case is plastic. Is it going that way? Seems to fit better. There we go, that fits a treat. So we'll keep it out of its case because we want the maximum range. As a possibility when you touch it, it's going to be better range. So put that back on power. We're running at 12 volts. And let's now put it on the aerial. So those of you who need adapters like this is an SO239, which a PL259 fits into. So it's SO239 to BNC, not S0239, SO239. Power on. One Nano Roger. That's the way on 23. There we go. Well, at least we've heard somebody on it. And we'll at least be able to plug our extension speaker in. So there we are, an unusual hand portable. But remember, they're not the 4 watts to say on the box, whatever it says on the box. 4 watts it says. Last one we did was about 1.5 watts, and this is about the same. Thanks for watching.